The last thing we're going to look at in these videos is how you use the Jacobian matrix to find the forces at the end effector given the torques at the joints. As it turns out, the way that you do this is very similar to the way that you transform velocities between the joints and the end effector by using the Jacobian. The force equation looks like this. This equation says that the torques at the joints are equal to the transpose of the Jacobian times the forces on the end effector. I'm going to expand each of the elements of this equation so you can see what each one contains. First of all, the force vector, which is the forces on the end effector, is a vector of 6 rows and 1 column. Very similar to how the end effector velocity vector contains 3 elements for linear velocity and 3 elements for rotational velocity, the force vector on the end effector contains 3 elements that are for the forces on the end effector in the x, y, and z directions, and 3 elements that are for the moments on the end effector. The joint torques, then, are also very similar to the joint velocity vectors that we've looked at in the velocity Jacobian. We have one element of the torque vector for each joint. So, for example, we have the torque of joint 1, the torque of joint 2, the torque of joint 3, etc. We'll have one element of this torque vector for each joint. The Jacobian, then, is the same Jacobian that we've calculated previously, it's just the transpose of the Jacobian. A matrix transpose is where you take the matrix and you make each row become a column instead. I'll show you a quick example of how you take the transpose of a matrix. Here's a Jacobian matrix that has 6 rows, as all Jacobian matrices do, and 2 columns. So this is a Jacobian matrix for a manipulator that has 2 joints. When I take the transpose of this matrix, it will look like this. To calculate the transpose, I'm going to take the first column of the Jacobian and I'm going to write it as the first row of my transpose. So, whereas the Jacobian has 6 rows, the transpose of the Jacobian will have 6 columns. Then I take the second column of my Jacobian and I write that as the second row of the transpose. And that's all there is to it. Once you've done all the work necessary to figure out the Jacobian, you have all of the information you need to use that for not only velocity but also for force.